Okay, so we're looking at a new type of differential equation with separable variables, which basically is a variable with a function of x and a second one with a variable of y. And what we do is we separate the dependent. So the dependent is the y function and the independent is the x function. Okay, but that's not the critical part. Okay, so let's just get this thing across. Okay, so we're looking at a few worked examples. So in the first one, obviously, we've got this is the separable, this is the dependent, and this is the independent. So what we're going to do is we're going to bring this across to the other side by division. So the next line would be 1 over y plus 3 dy dx equals x minus 1. Okay, and then what we're going to do is we're going to take the integral of both sides with respect to x, because then the dx's will cancel out, and then we've got on this side dx matching up with the x. So the dx's are going to cancel out. So on this side we've got a function integrating with respect to y, and on this side we've got a function integrating with respect to x. So on this side we've got a log function, so that's going to just be log y plus 3, and on this side we're going to have x squared over 2 minus x plus a constant. Now there's going to be a constant here, but the constant here can be moved across the constant here, so we just basically got one constant. Also we have to note that because this ends up being a log function, technically speaking y has to be greater than minus 3. Okay, it can't be equal to minus 3 because that would give you a 0 there, and we can't log negative numbers. Alright, so the next line would be y plus 3. To get rid of log we take exponentials on the other side. So we get x squared on 2 minus x plus a constant. Yep, and then the next line would be y equals e to the x squared on 2 minus x plus a constant, and then plus 3 becomes minus 3. And just to tidy up, we could break this up into 3 different components, and basically this e to the c will become a constant. So basically, just to tidy it up, and then just to make it look a little bit tidier, x squared minus 2x minus 3, where the constant out the front is e to the value of c. Okay, so that's the first example. So we'll look at a couple more. Get this line across. Okay, so why don't you have a crack yourself and see how you go. So pause the tape and have a go, and then come back when you're ready. Okay, so next line would be 1 over 3y plus 4 dy dx equals 2x minus 3. So, and then we can just go straight to 3y plus 4 dy equals 2x minus 3 dx. So on this side we've got a third log 3y plus 4 equals x squared minus 3x plus the constant, multiplied by 3 minus 9x plus 3c, so 3y plus 4. So we're going to go straight to a e to the 3x squared minus 9x, where a equals e to the 3c. So 3y equals 3. We can just factorise it now if you wanted, not critical. Plus 4 becomes minus 4. And y equals, some new constant, I suppose, e to the 3x squared minus 3x minus 4 and 3, where b equals e to the 3c over 3. Okay, so that factorising there is not critical. You could have left it as 3x squared minus 9x, not critical. Okay, that's it. Let's have a look next one. So in this next example, we're going to get information to find the value of the constant. Got another page after this. So have a crack. So look, obviously we've got skipping my notes, just hang on a sec. So I just had to pause the tape. So we've got P here and P here, so we're going to take, that's the P there, so we need to take the P's across and leave the Q's behind. Okay, so I'll work this one with you. So the next line would be 1 over P plus 3 dp dq equals, all that's left behind is 2q. And so eventually 1 over P plus 3 dp equals 2q dq. And then what we need to do is recognise that that is going to be your partial fractions question. So I'll just change. So we need to do a separate calculation to break it up. So 1 over P plus 3 equals A over P plus B over P plus 3 equals A, P plus 3 plus B times P, and that will be equal to 1. So, so make P equal to 0, so 1 equals 3A, so A equals a third, make P equal to minus 3, so 1 equals minus 3B, so B equals minus 1/3. So over this side now we've got A. So we've got 1/3 over P, and B is minus, I'll just put a plus sign for the time being, P plus 3 dP equals 2Q. So we've got 1/3 log P minus 1/3 log P plus 3 equals Q squared plus the constant. That's okay. So take the 1/3 out, and then we'll have P minus means divide, like that, equals Q squared plus C. So log P plus 3 equals 3Q squared plus 3 constants. P plus 3 equals E to the 3Q squared plus 3C equals AE to the 3Q squared, where A equals E to the 3C. So pause for a sec, hang on. Yep, it's back again. So we need an expression for P, so we're going to have to cross multiply to start with. P plus 3 AE to the 3Q squared equals P AE 3Q squared plus 3AE to the 3Q squared. And then we can bring, so P minus P AE 3Q squared equals 3AE to the 3Q squared. So P bracket 1 minus AE 3Q squared equals 3AE to the 3Q squared. Finally, P equals 3A 3Q squared over 1 minus AE 3Q squared. Okay, now we can look at the information at the start. So at the start it was P equals 10 when Q equals 3. So 10 equals 3AE to the 27 over 1 minus AE to the 27. So 10 bracket 1 minus AE to the 27 equals 3AE to the 27. Getting along. Let's pause for a sec. Now we expand out. So 10 minus 10AE to the 27 27. So 10 equals, that comes across, 13a equals 27. So finally, a equals 10 divided by 13e to the 27, and that's approximately 1.4458 by 10 to the minus 12. And that's basically it. So then the final formula would be P equals 3 times 1.4458 times 10 to the minus 12 times e to the 3q squared over 1 minus 1.4458 e to the 3q squared, and then just have to tidy up that number. I haven't got that with me on my thing, so finish that off by yourself. Okay, thanks for that one. And we've got one more page to go. So we've got a word problem application. So the rate at which a new social network expands is proportional to both the size of the network and the time since the network started. And then this gives us information for the constants, how long until there are 10,000 members. So we start off with, just have a read through that. So we start off with m is the number of members, and t is the time in weeks. Get rid of that. Okay, so let's change. Okay, so basically the rate of change of members with respect to time is proportional to both m and t. So therefore 1 over m dm dt equals kt. So 1 over m dm equals integral kt dt. So log m equals kt squared over 2 plus a constant. So m equals e to the kt squared over 2 plus c, which equals a e to the kt squared over 2, where a equals e to the c. And actually we can get rid of that 2 actually as well. So we've got a e to the kt squared, where a equals e to the c on 2. No, it's not, that's not right, hang on. So we can do that, but it's not equal to that, so it's just a new constant. Okay. So we've got t equals 2, members equals 30, so 30 equals, we'll call it b, e to the k times 2 squared, equals b e to the 4k, and second equation, t equals 3, members equals 120, and 120 equals b e to the 9k. Change the colours a little bit better. So we're going to combine those two equations. So we're going to divide. So 120 over 30 equals b e to the 9k over b e to the 4k. These cancel out. And then division is subtraction. So k, so 5k equals log 4. So k equals 1/5 log 4. And then we can chuck in into any of the equations. So we've got 120 equals b e to the 9 times 1/5 log 4. b e to the 9/5 log 4. So b equals 120 divided by e to the 9/5 log 4, and on your calculator, I got about 9.896. Right, change back. I'll change to the colour. Okay, so the formula m equals 9.896 e to the kt squared is the formula. Oh, k we know, so k is 1/5 log 4. And so the question is, when it's going to be 10,000? So 10,000 equals 9.896 e to the 1/5 log 4 times t squared. So 10,000 divided by 9.896 equals e to the 1/5 log 4 times t squared. So log of that number equals 1/5 log 4 times t squared. So t squared equals log of whatever that number was divided by 1/5 log 4, and t will equal the square root of whatever that number is, and from my approximation it was 24.95, and so we just take the positive, so it's about 5 weeks. Okay, so that last one was a bit hard, so you just follow through and we'll have some examples to do. Okay, thanks, bye.